Hi, this is Hafsa. Welcome to Quixotic.academy. In this video, we will discuss logic gates. We will see why logic gates are needed and what are basic logic gates, how they work, and what are their notations. So, most important thing about logic gates are they are Boolean. They take zeros and ones as input and they give output in zeros and ones. So we know that computer system uses binary numbers and binary numbers are only zeros and ones. There are multiple reasons. One of the reasons is they are less. They are just zeros and ones. Their quantity is less and their calculations are small. 0 multiplied by 0 can be 0. 0 multiplied by 1 is 0. 0 plus 1 is 1. And 1 plus 1 is also 1 in binary mathematics. Another reason is computer system is made up of electronics. There are resistors and there are chips and multiple stuff. So all of this stuff works by electricity. If the power is on, the thing work. If the power is off, it will not work. So 1 represents the on state of the system and 0 represents the off state of the systems, such as the light bulb in your room. Light bulb is on if electricity is flowing. Light bulb is off if electricity is not flowing. So similarly, computer system uses Boolean numbers. The next most important point is they take logical decisions. And what is meant by logical decisions? In your life, you see some people decide by heart and some people decide by using their brain. So when you make some decisions using your brain, you don't use emotions. You think about it, you think about the results, you think about all the rules and everything, and you make logical decision. So in short, when we use logic to make decisions, we seek to exclude emotions and use only preset rules. So these logic gates uses some preset rules to perform decisions on Boolean input. And when the decision is performed, the output is also given in terms of Boolean. First logic gate we are going to discuss is OR gate. OR gate is represented by using this symbol. It takes two Boolean inputs, perform some logical operation on the input and provide you a Boolean output. The logical operations performed in a logical gate are explained or explored using a truth table. Truth table is basically a table that contains inputs and outputs. So for OR gate, if inputs are 0, 0, the output is 0. If inputs are 0, 1, the output is 1. If inputs are 1, 0, the output is 1. And if inputs are 1, 1, the output is again 1. So it means output is 0 only once when both inputs were 0 and output is 1 in all other cases. So in simple words, you can say that OR gate is true or OR gate is output of OR gate is 1 whenever either of the input is 1. You can name the input any letter. For example, you can say inputs are C and D and output is Y. AND gate is represented by a D-like symbol. It also takes two inputs and gives you one output. So the truth table says that 0 and 0 is 0, 0 and 1 is also 0, 1 and 0 is also 0, 1 and 1 is 1. So AND gate gives you output of 1 only when both inputs are 1. If any of the input is 0, the output is also 0. In OR gate, the output was 1 whenever any of the input was 1. While in AND gate, if both inputs are 1, only then the output is 1. NOT gate is the loveliest and easiest of all. NOT gate is simply the opposite of input. It will take only one input and it will just reverse the input. If you give 0, it will give you back 1. If you give it 1, it will give you back 0. So we can just say output of NOT gate is opposite of the input. We did see how the logic gates are drawn and how are they represented symbolically. Now let's see how we can write them down in words. There are two methods. First is Boolean Algebra. Boolean Algebra is basically a mathematical field related to Boolean numbers. This field revolves around zeros and ones, all about zeros and ones. The second type is logical notation. Let's see how both are used. For the Boolean algebra notation, we use the small letters for the inputs and we write mathematical alternative for the gate. For example, plus for or, dot for and a bar for not gate. While in logical notation, we use the name of gate and we keep the letters capital. A or B, A and B, not A. To learn the Boolean notation easily, you can say that OR gate is actually addition, AND gate is multiplication, dot is a symbol of multiplication in vectors and in many other mathematical notations, while not can be represented by an inverse symbol or a bar above the input. Let's cover some advanced logic gates. One of them is Xor Gate. So Xor Gate is different than all other gates. 0 XOR 0 is 0, 0 XOR 1 is 1, 1 XOR 0 is 1, and 1 XOR 1 is 0. So what is your guess? So the output of Xor Gate is 1 if inputs are different. That's the easiest way to memorize it. Its logic notation is pretty simple, A XOR B, while its Boolean algebra notation is the complex one. A dot B bar, it means A and not B plus not A and B. So when you will be solving the logic gates and solving the logic circuits, you will understand this gate. NOR gate is a combination of OR and NOT gate. You will take an OR gate and apply NOT operation on the output of OR gate. That will be called NOR gate. The truth table says that 0 OR 0 is 0 and not 0 is 1. 0 OR 1 is 1, not 1 is 0. 1 OR 0 is 1, not 1 is 0. 1 or 1 is 1, not 1 is 0. That's how you will memorize it. You will just say that it is opposite of OR gate. The logic notation is pretty simple, A nor B, while the Boolean algebra notation is its self-explanatory, A plus B, not. So you will keep the letters small here. NAND gate is a combination of and NOT gate. So let's see, 0 and 0 is 0, 0 and 1 is 0, 1 and 0 is 0, 1 and 1 is 1. Now we will apply, it was A and B. Now we will apply NOT on the output. So it will become 1, 1 and 0. So this is the output of NAND gate. NAND gate will take the input, perform AND operation on the input, and then reverse the output. Its logic notation is A and B, while in Boolean algebra, A dot B and a bar above. If you have any questions related to the logic gates described in the video, you can comment below. Subscribe to the channel for more computer science related stuff.